All right, everyone, we're back for part 2 of our lesson 8.2, which is graphing in the form of ax squared plus c. So this time, we're starting on example 3, and here's what they want us to do in example 3. So they want you to start off by graphing this function right here, and then they basically want you to take that function and they want you to move it around, okay? So they just want you guys to be able to understand, like, not only how to graph, but how can I move it once I've graphed it in one spot. So let's start by graphing the function that I have, the f of x, circled in purple here. Okay, so we're just going to start by, graphing. So the first thing I'm going to do is I'm going to plug my vertex, or I'm going to plot my y-intercept, or whatever you want to call it. I'm going to put it right there. And then, although I don't have a table there for you guys, let's just quick go through and make one. So here's x, here's y. I'm just going to do -2, -1, 0, 1, and 2. Okay. So, like I said, I don't have one there for you guys. Just make one up quick. Maybe even just like right below, so that you've got a little bit of room underneath letter A, so that you can, so that you can still write down what letter A is asking you to do. Okay, so let's go ahead. Let's start plugging these numbers in. So again, if I plug 0 in up here, like this whole thing, this f of x or y is going to turn into 2. And then let's go ahead, let's do 1 and -1. So I'm going to do -0.5 times 1 squared, and then I'm going to do +2. So that's going to bring me to 1.5. Whoops, not 1.2, 1.5. And then, so each of those are going to turn into 1.5. And then if I do 2, so I'm just going to go ahead, I'm going to plug -0.5 times 2 squared, and then +2. So that's going to give me 0. Okay, so let's go ahead. I'm going to do, there's -1. I'm going to be up at 1.5. And then that's just going to be symmetric. And I'm going to be at -2, 0, and 2, 0. Let's see, I'm just gonna throw -4 and 4 in there just so that I've got a really, really good shape of the graph. And I'm picking 4 because 4 is gonna be, like, this 0.5 is gonna multiply nicely into that 4. It's a nice multiple. And so then when I do that, let's see. Yeah, then I'm going to come up with -6. So this up here will be -6 as well. I'm just going to draw a line there. I'm at -4, -6. And then same thing. All right. So there is f of x. Okay. Now you guys, also one thing, just kind of talking more about the shape and understanding the characteristics of parabolas. Notice how this one is opening down and it's negative. Okay, anytime you have a negative parabola, it's going to open down instead of opening up. All right, let's take a look at g of x really quick. So what they want you to do is they basically just want you to take this f of x function and they want you to move the entire thing down 7 units. Okay, so let's grab this vertex and we'll go 1, 2, 3, 4, 5, 6, 7. And then I'm going to do, let's see, I went down 1. Whoops, down half over 1. So down half over 1. And then if I go, let's see, over 2, then that would be down 2. over 2 down 2. Okay. So there is that new function. So that g of x I have drawn in blue. So now part A asks, describe the transformation from the graph of f to the graph of g. Okay, well, it didn't change in width, or it didn't get skinnier or wider, I guess I could also say. Really, the only thing that changed here, you guys, is that it moved down 7 units. Okay, so then going down to letter B, write an equation that represents g in terms of x. So we're basically just trying to come up with a rule or a function. Okay, so I'm going to start off with g of x. One thing that we know, it crosses this y-axis right here at -5. So I'm going to start by just plugging that -5 in there. And then, like I said before, the width of this, like the steepness, I guess you could also say, doesn't change at all. So this is still just going to be -0.5 x squared. So that's how we're going to treat that last letter B. I do not have an extra example of this one, but I can see if I can come up with something for tomorrow in class so that we can do an example of it if anyone's struggling with it. Okay. Oh, there's one right here. You know what? We'll do this one tomorrow in class because you don't have a ton of room left on your note sheets. So we'll just do that one tomorrow in class together. Okay. Last one. This is the last one we're going to do together. And then I want you guys to try the very last example on your own so that you've got a little bit of a idea how to do it. First off, we've got this function. We've got f of t equals -16 t squared plus s sub 0. Okay, so that's an important piece. That represents the approximate height of a falling object. One thing that you guys will start recognizing a lot is that if you're looking at a falling object, it's always, just because of the way gravity works, it's always going to be a -16. And then t squared. So just kind of something to get yourself familiar with and remember throughout the rest of your mathematical career and even physics when you get to it. So it represents the approximate height of a falling object t seconds after it's dropped from an initial height of s sub 0. Okay, so that s sub 0 is just the initial height. So then part A says, after, I've got to finish the word problem. An egg is dropped from a height of 64 feet. Okay, so I think our first step in this is to just go ahead and substitute this s sub 0 with a height of 64. Okay, so that's going to be first and foremost. Now, part A, after how many seconds does the egg hit the ground? There are 2 ways that we can solve this, you guys. And I think your book is probably going to want you to do more of the graphing side of things, if I had to guess. So I'm going to show you how to graph it, and then after that, I'll show you the other method that you can use. Okay, so let's just, I know I didn't give you guys a graph because I couldn't find one that would work really well. So you're just going to have to be really, really diligent and careful of setting your graph up. Okay, so my y-axis is going to represent the height. And then the x-axis, and that's technically in feet. And then the x-axis is going to be the time. And then that's going to be in seconds. Okay, so let's just do a quick little table over here. That's going to be t. This is going to be f of t. Remember, f of t and y are the exact same thing. So I'm going to do 0, 1, 2, throw a 3 in there. So let's start. If I plug 0 in here for t, I'm going to be starting at 64, okay? Let's just do, I'll have this be, I'll go up by 8s. So 16, 32, I've got 48. Okay, we'll just keep going with it. So then I'm gonna, okay, so there's 64. Good. Okay, so that's my starting spot. 0, 64. Let's try plugging 1 in now. So I plug 1 in. So I'm going to do negative 16 times 1 squared and then plus 64. Okay, so that's going to be at 48. Okay, so there's 1 and 48. And if I plug 2 in, so negative 16 times 2 squared plus 64. Ooh, that's going to be at 0. So that's going to be 1, 2, 0. That one's going to be right here. Okay, so here's that line. Here's that parabola that that egg is following right here. Okay, so I really don't even need the 3. I don't need to go any further than that because the egg has already hit the ground, and that's after 2 seconds. So the time is 2 seconds. Okay, so now our second method, and I'm going to go through this kind of quickly because this video is getting a little long. The second method, you guys, that we'd be able to do is we could just take this function and we can factor it, right? We just got done doing a whole bunch of factoring. So let's just start by taking out a negative 16. So that'll leave me with t squared. And then that's minus 4. And then we just got done talking a bunch about this. So you have a perfect square here, perfect square here. So that's going to be t and t. And then I'm going to do minus 2 and I'm going to do plus 2. Okay, so if you guys notice, remember that zero product property, right? We want this to equal 0. We want this to hit the ground. If I take each of these 3 pieces and set it equal to 0, right? T plus 2 equals 0. That's going to give me negative 2. So that's not going to work. Negative 16 doesn't equal 0 at all. So if I take t minus 2 and I set it equal to 0, t is going to just give me 2 seconds. Okay, so again, like I said, there's just 2 methods to do it. Part B says, suppose the initial height is adjusted by k feet. How will this affect part A? Okay, well, it kind of depends on what they're talking about by k feet. Does it mean that, like, k is going to be up, so we're moving the graph up? Because let's think about this. When you move the graph up, okay, so we're moving the graph up. Even if I just kind of look at where I'm starting here at 64. If I were to move this graph up to, let's say, even just 70, this time, it's going to take longer for that egg to hit the ground, right? So if you move the graph up, if you move that y value or that k value up, they're calling it this time, then the x-intercept will move and then that's going to move to the right, which means that it's going to take it longer. It's going to take a lot longer for the egg to hit the ground. Oh man, my pen is not working very well. I apologize. Usually it works a little bit better than this at least. Okay, so let's take a look then at what if you move the graph down? So when you move the graph down, okay, so we're taking this and we're moving it down, then the x-intercept will move. Wow, this is really bad. Will move to the left, which means that it's going to take less time, or it's going to be a shorter amount of time for the egg to hit the ground. Okay, I am done. I want you guys to try the next one on your own, see what you can do. Show me both the factoring, just as a little bit of review practice, and then also show me the graph. Okay, so there's two things I want you to try on this next one. Good luck. We'll see you tomorrow.